So we're in your chemistry book, chapter 11, selected metals and semi-metals. So we just finished chapter 10 that went over non-metals in the periodic table. And now we're going to go over metals and semi-metals, which are elements and very important elements indeed. So the vast majority of elements are actually metals and semi-metals. Non-metals make only a very small portion of the periodic table in all of our elements. So what about these metals? Why are they different? Well, let's look at table 11.1 here as a comparison of some physical properties of metals and semi-metals. Well, metals are high electrical and heat conductors. Their electrical conductivity decreases with increasing temperature. They're malleable, that means you can shape them into anything, and ductile, they can go through ducts like wires, and they usually have a metallic luster. They're bright and shining. Now, semi-metals are a little bit different. They're more of a combination of metals and non-metals. And they're intermediate electrical and thermal conductivity, so in between. So although you'll know semi-metals because they use them in computer chips, but actual electrical conductivity increases, this is the opposite, with increasing temperature. They're brittle and they have just a slight luster. They're not shiny. So that's the difference between metals and semi-metals. So let's go into 11.1, which is metallurgy. What is metallurgy? Have you heard that name before? Well, the definition is that it's a complex process to extract metals from their source. So going through this process, you actually have to get the ore, the metal ore, out of whatever other minerals are, keeping it together, or they're in the minerals. Such minerals, like most metals on the other hand, occur in the earth in the form of minerals, generally as silicon or silicates, sulfates, carbonates, oxides, or sulfides. So we're going to go over these complex processes to actually get the metal out of the ore. So what is the ore? Well, the ore, it basically is a natural occurring material containing the metal that's in sufficient concentration to make the extraction profitable. So basically, the ore is where the metal is hiding in the ore. So as we go on, we're going to go through how we can get this through the ore. Now, they went through and this concentrated in all these, and it's kind of complicated if I read it. So I kind of put it together so it'd be easier for you to understand. So let's go over my notes here. Move this over here a little bit. Okay, let's see. I'm gonna move this down a little bit, I think. Get it to go down. Sorry, it's not doing that. So, okay, we'll put it up instead. But anyway, so here's my notes, the steps. So let me just hold this here. So I'm going to be holding, I might move a little bit here. So first of all, the first step here has to do with the grinding step, the first step. So the first step is where they crush and grind the minerals in the ore, I should say, to try to get it out. So they crush it all up, and then they use a flotation. The flotation is where, in the midst of this, they mix all this with water and detergent in this huge tank, and they agitate it around, and certain parts of the mineral froth flows up to the top, and then they skim off the top. Now the gangue, what's the gang? The gang is the part that you don't want, that sinks to the bottom of the tank. So they're gonna skim off the top to get that mineral. So that's the first. They haven't heated it yet. They're grinding and the crushing, and then with water skimming off the top. So that's the first step. The next step is the reduction step. And this is where temperature comes in. And so they're going to reduce the free metals and basically, they're going to gain electrons, and the flux is going to deal with a gang that's left over, so in the midst of this. But the reduction process reduces the metal to this free metal. So now we need a high temperature for reduction to do this. And the reduction temperatures and such varies in the process from metal to metal, and which one works the best. So that's reduction. On to the next step, number 3, is refined. Well, what is refined? Well, refining process extracts the metal to the desired purity. So it used a technique as electrolytic, or electrifying, I should say. So in the midst of this electrolytic refining, putting electricity through, and also with oxygen, sometimes with putting oxygen at high levels, this causes another step in the refining process. So in the refining process, this oxygen process basically leads to step 4. And in step 4 is the desired object. So we're going to receive the desired object. And the step 4 is the shaping of casting and molds. So basically at high temperatures, you take the ore, as the ore is in a liquid form, and you cast the ore into different molds, or you roll them into sheets like steel would be, into long sheets of metal. And sometimes they mix them with alloys to make them stronger, especially when you're talking about iron and steel, right? They mix them with different alloys. They might mix iron, iron and bronze or tin or copper, whatever they're going to do. They're mixing alloys of certain elements together to make them stronger. So let's look back over this. For the steps you'll need to know. First step is grinding and crushing, and this has flotation, which they wash it with water and skim off the top, and the gangue that they don't want falls to the bottom. The reduction is the next step, and that's where they increase the temperature to high temperatures, whatever they need to reduce the free metals. And sometimes this is electrical. As this goes through, it will have them gaining electrons. I wouldn't say that this is electrifying, but at this time there'll be reactions because of the temperature in the midst. So if you're getting an ore out of a mineral. So onto the refining process, and that's the electrolytic refining, putting electricity through, or sometimes high oxygen, basically putting oxygen at very high levels. And then on to the shaping, and that's the molding, and casks are rolling them out into sheets and mixing them with alloys. So just you know, that's actually what this first part of the lesson is about, is talking about how to get a metal out of the ground, right? So let's go from there. I'm gonna move this over here so we can see better. Sorry here. Well, let's go ahead. That's about it for section 1. There were some questions here. Well, I gotta do this again here, sorry. I don't know what it's making me sign in again. Crazy. Okay, so let's go to the questions. Real quick. What is metallurgy or metallurgy? Metallurgy basically is extracting the metal from the ore source, right? Pretty easy. What is an ore? It's a naturally occurring material containing metal sufficient to that we could make an extraction and it'd be profitable. So ore is actually where the metal is hiding. And of course, the 4 steps, do you remember them off your head? Grinding first, reduction, where is high temperatures, refining, put electric current through it, and high oxygen levels to refine it, and on to shaping or molding it. So those 4 basics. So that's all for this section. I was going to do another section on this, but let's do it in another video.